All right, made some more progress on the Mom's Timer project. Today I wanted to get the ATtiny set up so that I can program it. And I hooked everything up and threw together a little program to test out some of the features. And seems to be working pretty good. I also did something I've been avoiding for a while, and I upgraded I'm testing at least the Arduino, the latest version of the Arduino development environment. I've got 1.6 going here too. So it seems to be working okay. It's a little different, but I'll kind of show you what I found. So this little test program that I did, what it's doing is just reading this light sensor here with one of the analog inputs, and then it will do it'll adjust how quickly it blinks this LED based upon the light that it's detecting. And then also this LED over here, which is kind of acting funky, what it's supposed to do is change its brightness based upon how much light there is. And then the final thing that I'm testing is I've got an FTDI adapter here hooked up to a couple of pins, and I'm testing out the software serial library, making sure that I can send some data through the serial to a serial monitor. And right now I'm just sending the brightness level that's being detected. If I put my finger over it, the brightness level is lower, and then if I remove it, it goes back up. So the software serial is working just fine, and the analog read, so the analog read is, reading this is working okay. And then analog write is doing the brightness of this LED here. So working pretty good. The hookup was pretty straightforward. It just has those 4 programming pins like the other microcontroller had, the MISO, the MISO, the S clock, and the reset. And it was easy to look at the data sheet to see what pins those were. And then to program it, what I was doing was looking online to see what is the most popular library for making it so you can program ATtiny with the Arduino development environment. It seems like there's 2 of them. There's High-Low-Tech, and then there's one that's on Google Code. It's just called Arduino Tiny. And what I did was, at least on the High-Low-Tech, I can show you. They have a really nice write-up on basically what they're doing, and here's the zip file to download it. You have to, if you have Arduino 1.6, it's got a different folder structure, and they've really changed the way they do the libraries in 1.6, so that's why they have a separate download for that. But anyways, this goes into a lot of detail, how it works, how to hook it up. It shows you the pins that they provide with the library. So I've got an ATtiny84 on here, and so they make this Arduino pin 0 all the way 5, 6, all the way up to 10, and then you get analog input pins. You get analog input 0 all the way to 7, and then for PWM pins, where you can do like fading of LEDs and stuff like that. The analog write command, you've got 4 of those. There's a PWM pin here, then one there, and then one there. And then they also, listed out which pin is the VCC. Here's the ground. Here's the reset, and then here's the MOSI and MISO S clock. So those are those programming pins. And they even show you, here's the Arduino commands that should work okay out of the box. So the software serial I'm using, the digital or analog read, the analog write. It's working just fine. The delay. So very happy with that. So the other one, the Google one, they don't have a whole lot of write-up on this particular page, but there's a lot of other websites out there that kind of talk about it and use it. So they actually link to that High-Low-Tech one, and the High-Low-Tech one actually linked to the Google one at the bottom. Here's the ATtiny one. So So I downloaded the libraries just to see what was inside of them, and I put them in this tiny course folder. I just downloaded their zips and expanded them. And the one that's the high-low tech one is this one here, and it's pretty simple. They have a couple text files here to define the boards that they support, and then there's this variants folder, and they have a pin mapping file for ATtinys that have got 8 pins, and then another one with ATtinys that have got 14 pins, and that's it. So there's just 4 files in this thing. The Google hosted library, it's a little bit more complicated. So they've got you know, those boards file and stuff, and then there's this bootloaders folder. It has a bunch of 1K hex bootloaders. I guess these are empty. I'm not sure what these are. It just says empty on them. And then the cores area, there's, you know, there's some files, and then there's this tiny folder here with all kinds of files to do stuff. It looks like it's an entire repeat of, you know, the normal Arduino. Well, not an entire repeat, but a lot of repeating of what the Arduino just gives you on its own, normal IDE. So just based upon this, I decided to go with the high-low tech version. And it's got, you know, the features that I was looking for, and it's a lot simpler. So to install the library, you just take the folder that you unzip, and then in your Arduino folder, which I just put here, there's a hardware folder, and you just normally it just has Arduino and then tools, and I just dropped in this ATtiny one, and then that's it. And pretty easy. So when once you do that, then you open up your IDE, and then in the tools menu under the board, you can pick ATtiny. It'll show up as something that's available, and then you can set the speed that you want to run it at. Like I'm running it at 8 megahertz. One trick: you have to run it at 8 megahertz for software serial support. If you set it to be 1 megahertz and you try to compile it, it actually gives you an error compiling, and it's just because the speed isn't fast enough. So if I do 8 megahertz internal, then that actually compiles okay. Very, very interesting. So you set the speed, and then you pick which ATtiny you've got. So I've got the 84 here, and then oh yeah, for the programming, I wanted to show. I do have a couple different dedicated programmers, and this is one of them. This one is called the USBTinyISP, and it's available by default in the Arduino IDE. You can pick it to be your programmer, and you can buy these on Adafruit. You gotta open up the tab for it. So it's just a kit, and you solder together. But I don't much care for them. I've had a lot of issues with this one where it just randomly won't upload, and I have to basically just reset it. I have to just unplug it from the USB and plug it back in, and then it starts working again for a little while. And then the other thing I don't like about it is they have a pin on here that you're supposed to be able to remove so that you can power the board with a like a battery pack or something like that, and all this thing does is act as a programmer for it. And you know, it won't power, it's not supposed to power anything, but it does. In fact, I did hook up the voltmeter here to show you. So it outputs right now on this little circuit 3.8 volts when I have the little external power pin here. If I put it back on, it'll go back up to the normal USB. That's the default thing. It goes up to the USB voltage. But if you remove it, you know, it still provides power to the board. And in my case, you know, I could fry one of these things or damage them, because you're not supposed to put too much power through these things on their VCC pin. So that's no good. And I contacted Adafruit, their forums, their support forums. They sent me another one of these microcontrollers to stick in here. They sent me another one of these buffer chips to solder in. I had to clip out the one I had before and put a new one in. They had me take a picture of the front and the back of the board so they could look at the soldering job. It all looked legit, and this really just doesn't work. So I actually found that using Arduino development board as a serial and circuit serial programmer it works better than this guy over here for some reason. So I was using this, to get started, but I just took this up just to show you that you could use those as well. And there's the connector for it. But the Arduino, you hook it up to the exact same pins, and this works just fine. The programming of it is exactly like the normal Arduino. I just included the software serial library. This is just the default software serial library that is part of Arduino. You saw the high-low tech zip file that didn't have anything special in it. And then I just defined some pins, and I created a software serial object. You just tell it what RX and TX pins you want to use. I just made them 9 and 10. And then you just do a begin with the baud and set my outputs and my input. LDR is light dependent resistor. And then the loop, I just read the ambient light. I test out the serial. So if I wanted to test out sending and receiving, so you can do a while loop, and if there's any serial characters available, it'll just spit them right back out. It'll do software serial read and then software serial.write, and while there's characters available. And that works fine. And then I output the brightness or the ambient light level that I read. And then I do the test the analog write. So when you do analog read, you get 0 to 1023 as a value. And I'm just doing a mapping here to change it to be 0 to 255. And just to make it brighter, my light isn't going all the way from 0 to 1023. It's only going from like 20 to 300. So this kind of grabs it. I do the analog write, and then I just do blink that other LED based upon the ambient light level, how bright it is. And that's it. I think I showed this already, but yeah, you just pick your programmer as your USB ISP, because that's what I'm using right now, and you just hit the upload button, and it'll upload it. See if it freaks out. It's amazing how often it doesn't work. I'm very surprised by it. So it says it did it, and it shows a bunch of errors. It always shows a bunch of errors, but it actually didn't do it. As you can see, it's not working here. So let me try it again. This is what I mean about this thing. It's just very inconsistent. I don't know, maybe I have a dud. Maybe my circuit board is no good or something. They didn't send me a whole new kit to put together, but this one doesn't work very good. Okay, so now it worked okay. You still get a bunch of errors down here. By the way, you don't get those errors when you use your development board as if you do the Arduino as ISP. But yeah, it seems to be working. That's okay. Let's see if the serial output is okay. So it's showing there. And if I type in stuff, it'll just repeat it back with that while loop we did. So that's perfect. So that means it's sending and receiving with the software serial. So yeah, that's it. Another good day. Got the little microcontroller working that I'm planning to put into the key fob in Mom's timer. Alright, well, I figured I'd show the last programmer that I got. What the heck? Let's finish it all in this video. So this is called a AVR Dragon, and it's very bare bones. It just comes in a box. There's no cables or anything. You have to supply your own. And it is used, it works just like having your Arduino work as a circuit serial programmer, or that other, this one from Adafruit that I don't like at all. The thing that is nice about this one is it's got some more capability. There's I haven't used it yet, but it has this hardware breakpoint capability that they talk about, where you can, at the hardware level, set breakpoints, change registers, look at registers, changing in real time. Even on these little ATtinys, it supports all that stuff. And it has high voltage programming. There's a little pin header for that, and JTAG, more advanced, or I don't know if it's more advanced, but just different ways of programming than the little 6-pin header that all the other ones use. But it hooks up the same way as all the other programmers, MISO, reset, all that good stuff. But unlike the USB Tiny one, it works properly and it does not output any voltage on its line, and it just uses whatever the voltage is of the circuit. And so just for my little circuit here, I've got an FTDI adapter set up to be 3 volts, and I'm just grabbing the power off of it and running the circuitry off of it. But you can see it does have a little prototyping area, and you could put a little voltage regulator on here and create a 3.3 volt output on this. They give you a 5 volt pin, and so you could actually create any voltages that you want and hook it up to that. So so yeah, this is the other programmer that I've got. Works awesome, works great, never had any problems with it, and doesn't act weird, never have to unplug it. Can't say enough good things about it. It just works. So to get it to work with the Arduino IDE, I'll show you that. So normally you're not going to have a Dragon listed in here, an AVR Dragon. So what I did was just looked online and figured out how to get it added. So within your Arduino folder structure, there's a hardware, and then there's Arduino, and then with Arduino 1.6 at least, there's this AVR subfolder, and they have a programmers text file. And this is where all those programmers are being defined at. And what you can do is add an entry for the Dragon, and for Arduino 1.6, here's that path again. And then these are the values that you need to put in to get that Dragon to show up. And then for Arduino 1.0 environments, it's a little bit different, but basically the same. So you can just copy and paste this in, and I'll just stick it here, I guess. You just save, and then you can open up your IDE again and it'll show up. So tools and programmer, and there it is. In my case, it doesn't work right off the bat because I've got Windows 7 64-bit, and there's some kind of incompatibility with avrdude for it. It says this here, can't find the USB device. But after some Googling, discovered that you could install this driver library. I guess it provides like a Windows 32 USB support for it. And so you just download this driver library. It's got a little wizard in it to allow you to generate this 32-bit driver. And you just have to pick which device you'd like to generate the driver for. We'll pick the Dragon. And then it will ask you to put the driver files that it's going to create in a folder. So pretty easy. And then after it generates the driver, you can also install it if you want. I'll just go ahead and do that. And that's it. So now if I come back here and I hit upload, then we get all the flashing lights like we're supposed to, and it programs it just fine. So this was $50 for this programmer debugger thing, but there's also another Atmel programmer that I wanted to show. So Dave Jones did a nice video on how he hacked his. It's called the AVR ISP Mark II, and they're a little bit over $30. So only like 10 bucks more than that USB Tiny ISP one. And it's a proper, programmer. It doesn't output 5 volts on its line. And Dave Jones just changed his so he could switch 5 volts on and off and 3.3 volts on and off. He tapped into the USB power that was coming into it. So yeah, that's the the AVR ISP Mark II. And that's all I know about programmers. So everything is in this one video.